So good afternoon all of you. Let us start the problems based on division by t. So I am writing here problem number 1. So first problem is find Laplace of sin t by t. So this is the first problem. Now yesterday we have done the proof of division by t, that is, I'll read the statement once. If Laplace of f of t is equal to f bar s, then Laplace of f of t by t is equal to integral s to infinity f bar s ds. So provided the integral exists. So we'll apply that here in this problem. So first we write the solution. So here first we have to take f of t. So the problem is in the form of Laplace of f of t by t. So f of t is equal to sin t. Then we find the Laplace of this function. So Laplace of f of t is equal to Laplace of sin t. So this is equal to, as you know, Laplace of sin at is nothing but a by s square plus a square. So I can write here a is 1 here in this problem, that is Laplace of sin t. I can write 1 upon s square plus 1. So this is nothing but f bar s, as we have discussed, as we have done many problems based on that in the previous sessions. Now you can see, now we are applying now division by t here. So as you know, the problem is given Laplace of sin t by t. So that is in the form of Laplace of f of t by t, that is equal to integral of s to infinity f bar s ds. So that is also equal to, you know, we got just now, we have done Laplace of sin t is nothing but 1 by s square plus 1, that you know, that is f bar s. Now I can write integral s to infinity f bar s is nothing but 1 upon s square plus 1 ds. Now after this we have a formula, you know, since integral of 1 upon x square plus a square dx is equal to 1 upon a tan inverse x by a. You know this, you have studied in your intermediate. Now when you apply this formula to this one, then this becomes tan inverse 1 by a. A is nothing but here 1, x is nothing but here s. So when you apply here in this, you get tan inverse 1 by a in the sense 1 by 1, tan inverse x by a in the sense here we have x as s, so s by 1 you get. So tan inverse s, tan inverse s. Now you get this. Now limits are s to infinity. Now this is equal to tan inverse. Now when you apply the limit to s, so this becomes tan inverse infinity minus tan inverse s. Now this is equal to, now tan inverse, we can write infinity as tan pi by 2. As you know, tan pi by 2 is infinity, so in the place of infinity I am writing tan pi by 2 minus tan inverse s. Now I can cancel tan, then the answer is pi by 2 minus tan inverse s. So this is the solution of the given problem. In this way we do the problem based on division by t. So clearly the problem will be given in the form of Laplace of f of t by t. If you find this type of problem in the exam, you have to apply division by t, and we have to solve in this manner. Now let us do the second problem based on division by t. Second problem I am writing here. Now this is the first problem we did. Now let us have second problem based on division by t. Second problem, this is very important problem. We have seen this problem repeatedly in the previous papers. So find Laplace of cos at minus cos bt upon t. So this is the problem. Now as you see, this problem is in the form of Laplace of f of t by t. So if it is the form, then we solve the problem based on division by t. Now first, for that we write the solution, and we write given or let f of t. What is f of t here in this problem? In this problem, f of t is equal to cos at minus cos bt. Now first we find the Laplace of this f of t, and then we'll proceed for applying division by t. So Laplace of f of t is equal to Laplace of cos at minus Laplace of cos bt. Then this is equal to, as you know, Laplace of cos at is nothing but s upon s square plus a square minus s upon, here we have in the place of a as b, so cos bt can be written as s upon s square plus b square. Now this can be taken as f bar s. This is nothing but we have just got Laplace of f of t as this one. Then now we apply division by t. Cos at minus cos bt upon t is equal to, you know, that is nothing but I write the given problem is in the form of Laplace of f of t by t, that is equal to integral s to infinity f bar s ds. So when the problem is given in Laplace of f of t by t, first we find Laplace of f of t so that we can get f bar s, so that we can substitute directly here in this. So now this is equal to integral 0 to s to infinity, s to infinity f bar s is nothing but s upon s square plus a square, I write ds here, minus integral s to infinity s upon s square plus b square ds. So after writing this, now here you have to see whether we can get any, we can apply any formula or not. Here we can apply the formula, but we have to multiply and divide by 2 first. So when I multiply and divide by 2 for this first part, so this becomes 1 by 2 into 2s upon s square plus a square ds, minus in the same way I am multiplying and dividing to the second part of this, so this becomes 1 by 2 2s upon s square plus b square ds. Now after applying, now you can see this is in the form of integral of f dash x divided by f of x. This is also integral of f dash x by f of x. So here we are integrating with respect to x. So here f of x is s square plus a square. When you differentiate with respect to s, you will get 2s, that is in numerator you can see, and this a square becomes 0. In the same way it applies here. So now I can write this as, when you have a formula like integral of f dash x by f of x dx is equal to log f of x. So I can write here 1 upon 2 I'm taking 1 by 2 common here. So if I take 1 by 2 common, then I can write this as log s square plus a square. Now you can see I'm writing here for this integral of f dash x by f of x as log f of x minus log, for this also, log s square plus b square. Now as the limits are same, I am writing here s to infinity. So now when you apply the limits, then or before applying the limits, you can see this is in the form of log a minus log b. So I can write this as 1 upon 2 in bracket log s square plus a square upon s square plus b square. You put the bracket and just put box, and then what are the limits here? We have s to infinity. Then after writing this can be written as 1 upon 2, and then inside what I do is I take s square common. If I take s square common, then this becomes 1 plus a square upon s square, and then here also in denominator I take s square common, then this becomes 1 plus b square upon s square. Just close the bracket, and here also you close the bracket, just put the limits now. So limits are s to infinity. Then after this you can cancel this s square. Then after cancelling this, you will get half in bracket log, you will have now 1 plus a square upon s square plus 1 plus b square upon s square, s to infinity. Now when you apply upper limit minus lower limit, then this becomes 1 upon 2 in bracket. Now you can see log, you get, when I am applying upper limit now, upper limit is infinity, so in the place of s I have to substitute infinity. So this becomes 1 plus a square upon infinity upon 1 plus b square upon infinity minus, when you apply lower limit, this becomes log 1 plus a square upon s. You are substituting, you are applying lower limit to s here, so you get 1 plus a square upon s square upon 1 plus b square upon s square. So we have applied upper limit as well as lower limit. Now here you can see 1 plus a square by infinity is 0. Here 1 plus b square by infinity is 0. So I can write this as this is equal to 1 by 2 log, put the bracket here. Now I get log 1 minus log, you will get 1 plus a square upon s square plus upon 1 plus b square upon s square. Just close the bracket. Now you know log 1 is nothing but 0, so I can write this as 1 upon 2 in bracket, so writing 0 here, then log, now cross multiply this becomes s square plus a square upon s square upon s square plus b square upon s square. Then the last step is 1 upon 2 log, I can write this as s square plus s get cancels here, so you will get minus log 1 by 2 log s square plus a square upon s square plus b square. So this is the answer for the given problem. Now let us do, or we'll go for next topic. We'll do two problems. We have done two problems. Now we'll go for next topic, that is evaluation of integrals. Now we write here the topic name, evaluation of integrals by Laplace transforms. This is the next topic. We have completed two problems based on division by t. Now we will do the problems based on this. Now first problem is using Laplace transform, evaluate integral 0 to infinity t into e power minus 3t dt. This is the next problem. This is the problem based on evaluation of integrals by Laplace transform. Now let us do this problem. Now first, if a problem is given with e power minus 3 accompanied by e power minus 80 or e power 80, then we will solve the problem like Laplace of, first I find the Laplace of f of t, that is Laplace of t is nothing but, as you know, the formula for Laplace of t power n, that is n factorial by s power n plus 1. So by using that formula I am writing here this is equal to 1 upon s square. As you know, I'll write here Laplace of t power n is equal to n factorial upon s power n plus 1. Now from this formula we have got Laplace of t power 1 is nothing but 1 by s square. So after finding that, we have to write this implies integral of 0 to infinity e power minus st into t dt is equal to. Now whatever problem is given we have to write here once. So that is nothing but, here when you apply integration by parts for this, you get again 1 upon s square. This is for you. You have to apply integration by parts for this and apply the limits, and see, you will get 1 upon s square. So after getting that, you have to put here s is equal to 3. When you put s is equal to 3 here, then this implies integral 0 to infinity e power minus 3t into t dt is equal to 1 upon, in the place of s we are putting 3 here, so we'll get 9. So this will be the answer. Here it was asked for 2 marks in the previous papers, so this type of problems will be asked. So if a problem is asked in this way, you have to do in this way. So the problem will be asked, the problem will be like some function of t accompanied with e power minus at or e power at. Let us do next problem so that you can understand here. So second problem is evaluate integral 0 to infinity e power minus 4t sine 3t dt. Now for this problem you can see, first in the previous problem, first I have solved Laplace of f of t. Here also I'll do that same. So here you get Laplace of sine 3t. You can see here f of t is nothing but sine 3t. So I am writing here Laplace of sine 3t is equal to 3 upon s square plus 9. As you know, Laplace of sine at is equal to a by s square plus a square. So a is 3 here, so I have written 3 upon s square plus 9. So after writing that, now Laplace of e power minus 4t, here instead of writing Laplace of, you have to write integral of 0 to infinity e power minus 4t sine 3t dt. You will get 3 upon s square plus 9. After that, what we have to do, we have to put s is equal to 4. So if you here we have to take e power minus st. See, integral 0 to infinity e power minus st. Here also we have taken integral 0 to infinity e power minus st t dt is equal to 1 by s square. In the same way, integral 0 to infinity e power minus st sine 3t dt is equal to, we have to write 3 upon 3 square plus 9. Put s is equal to 4. So if you substitute s is equal to 4 here, you get 0 to infinity e power minus 4t sine 3t dt. So this is equal to, you get 3 upon, in the place of s you are substituting 4, so that becomes 3 upon 16 plus 9. So that is equal to 3 by 25. So here most of you are getting the doubt how you got integral 0 to infinity e power minus st into t dt is equal to 1 by s square. So when I solve, I'll show you how you will get. Here you have integral 0 to infinity e power minus st into t dt is equal to, I am applying integration by parts. You know integration by parts. So first I have to see Eilert rule. Now here this is exponential, this is algebraic, so you have to take u and this is v. Now where you apply uv formula, integral, you know that integration of uv dv is equal to u integral v dv minus integral of u dash integral of v dv dv. So this is the formula, you know. So when here we have limits, so here v is this one. Now I write here t into, now when you integrate e power minus st, so you get my e power minus st by s, because you are integrating with respect to t. Now after that you have to apply the limits. So limits are 0 to infinity minus, then integral of u dash is here t, so you are integrating with respect to t. If you integrate with respect to t, so d by dx of x is 1, so d by dx of t, d by dt of t is 1, so I write 1 into integral of v dv is nothing but this one, so I write here e power minus st upon s, and then we write dt. Then afterwards we will get here when you apply the limit. So here we have 0 to infinity. Now you can see, now when you apply limit to t here, e power minus infinity is 0. When you apply upper limit, that becomes 0. Then lower limit if you apply to t, that becomes 0. So first part is 0 here. Then when you integrate again this one, here you get minus. Then let us see. Now when you take this 1 by s outside, then this becomes integral of 0 to infinity e power minus st dt. Now when you integrate this becomes minus 1 by s. Now e power minus st upon minus s, okay, dt. This becomes e power. Now when you apply the limits here 0 to infinity, so this becomes e power minus st upon, wait a minute, this s goes there, so this becomes 1 by s square you get here. Now you will get e power minus st, now 0 to infinity here. Now when you apply 1 upon s square, now e power minus infinity minus e power 0, you get 1 upon s square, so e power minus infinity is 0 minus 1. So this is the answer you get. So you should get 1 by s square. So let us check once here. E power minus st, so e power ax by a, so here we have e power minus st, so we have to take only s here, so that becomes, so now here we are applying minus infinity to t, so that becomes e power minus infinity 0. When you apply 0 to this one and t, so this becomes 0. Now when you apply here, so here you will get minus 1 by s. Now minus 1 by s here. Now here we will get when you integrate this one again, here you will get plus. Now this s goes outside, so this is minus 1 by s, 1 by minus 1 by s square. Now e power minus st, here limits are 0 to infinity. Now here you can see, here if you have minus here, you have minus here. Now when you apply infinity to here into t, so e power minus infinity, and then if you apply 0 to t, that becomes e power 0. E power minus infinity is 0, e power 0 is 1, so minus of minus, when you multiply minus 1 by s square inside, that becomes 1 by s square. So when you apply integration by parts, then you will get 1 by s square. So we have to take here 1 by s square. Then after that we have to substitute by seeing in the problem it is given e power minus 3t, so we have to substitute, put s is equal to 3, so that it becomes integral 0 to infinity e power minus 3t into t dt is equal to, where here 1 by s square we have, so we have to substitute s is equal to 3, so that it becomes 1 by 9. So in the same way, in this problem also, first we have to find Laplace of sin 3t, so that it get 3 by s square plus 9. Then after finding by using integration by parts, now here it becomes a formula, that is nothing but integral of e power ax sin bx dx. So when you apply that and applying the limits, you will get 3 upon s square plus 9. Here you have to apply the formula integral e power ax sin bx dx, that is equal to, you know the formula, integral of e power ax sin bx dx is equal to e power ax by a square plus b square in bracket a sin bx minus b sin a sin bx minus b cos bx. So when you apply the formula again, you get 3 upon s square plus 9. Now when you substitute s is equal to 4, then you will get the answer 3 upon 25. So this is the second problem based on evaluation of integral by Laplace transform. Now let us have the next topic. The next topic is inverse Laplace transform. Now inverse Laplace transform this is the next part of this unit, this is second part. First part is Laplace transform. In Laplace transform we have completed the definition of Laplace transform, then linearity property, then afterwards we have started the problems based on elementary functions. After completing that, we have completed first shifting theorem, and then we have done problems based on first shifting theorem, and then we have written the definition of Heaviside unit function, and then we have done second shifting theorem. We have proved all these theorems, and then we have done problems based on second shifting theorem, and then we have gone for Laplace transform of derivatives, then Laplace transform of integrals, and then afterwards we have done division by t, and then we have done some of the problems based on evaluation of integral by Laplace transform. So this was the first part of unit 5, and then after this we will have second part, that is nothing but inverse Laplace transform. Inverse Laplace transform. In inverse Laplace transform, let us write if Laplace of f of t is equal to f bar s, comma, then f of t is called as inverse Laplace transform of f bar s, and it is known as, or it is written as, L inverse f bar s is equal to f of t. So this is the definition of inverse Laplace transform. In inverse Laplace transform, you can see inverse Laplace transform. If Laplace of f of t is equal to f bar s, you have seen in Laplace transform, that is Laplace, where you apply Laplace for f of t, you will get f bar s. Then f of t is called inverse Laplace transform of f bar s, and it is written as L inverse f bar s is equal to f of t. Now let us write Laplace transform of some elementary functions here, inverse Laplace transform. So now we will write formula. So when you write the formula, first one is Laplace of L inverse of, here we are dealing with inverse Laplace, so L inverse 1 by s is equal to 1. As you know, in the previous topic Laplace transform, Laplace of 1 is equal to 1 by s. Here L inverse of 1 by s is equal to 1, so this is vice versa. So now second one, L inverse of 1 upon s minus a is equal to e power at. There in Laplace transform, Laplace of e power at was 1 upon s by a. Here L inverse of 1 by s minus a is equal to e power at. So now that is next third one, L inverse of 1 upon s plus a is equal to e power minus at. Now whatever you have studied in Laplace transform, here we will take the vice versa of that. So Laplace of L inverse of 1 upon s square plus a square is equal to 1 upon a sine at. As you know, Laplace of sine at is equal to a upon s square by a square. Here L inverse of 1 upon s square plus a square is equal to 1 by a sine at. So this is somewhat different. Now L inverse of s upon s square plus a square is equal to cos 80. Now sixth one, L inverse 1 upon s square minus a square is equal to 1 upon a sin hat. Seventh one, L inverse of 1 upon L inverse s by s square minus a square is equal to cos hat. Eighth one, L inverse of 1 upon s power n is equal to t power n minus 1 upon n minus 1 factorial, that is also equal to t power n minus 1 upon gamma n. Here n is real and here n is positive integer. These are the 8 formulas which we repeatedly use in the problems. So let us do problems based on inverse Laplace transform based on these elementary functions. Let us do first problem based on this. First problem is, let us write problems here. First problem is find L inverse 3s plus 5 upon s square plus 4. This is the problem. First problem is find L inverse 3s plus 5 by s square plus 4. Now let us do the solution of this one. First write here, we'll write f bar s, that is here in inverse Laplace you will get f bar s, then you have to change in terms of t. The solution will come under t, whereas in Laplace the function will be given in terms of t, then applying Laplace we have to get in terms of s. So here f bar s is given, that is nothing but 3s plus 5 upon s square plus 4. So this is equal to, we can write this as 3 into s upon, I can write this as s square plus 2 square plus 5 upon s square plus 2 square. I am just separating this 3s by s square plus 4 plus 5 by s square plus 2 square. Okay, so after taking that, now when you apply L inverse for this, L inverse of 3s plus 5 upon s square plus 4 can be written as, I can write here 3 is there, so I can write 3 constant, so I can get 3 L inverse of s upon s square plus 4, that is 2 square plus 5 I take outside, I'm sorry, L inverse 5 L inverse 1 upon s square plus 2 square. Now you can see this is equal to, this is 1 and this is 2. Now 3 into L inverse of s by s square plus 2 square. When you see the formulas, now you can see here L inverse s upon s square plus a square is cos 80. So here we got L inverse of s by s square plus a square, so we can write cos 2t because a is 2 plus 5. Now here we have L inverse 1 upon s square plus 2 square, so you can see here L inverse 1 upon s square plus a square is 1 by a sin 80. So I can write here a is 2, so I can write this as 5 into 1 by 2 sin 2t. From the formula L inverse 1 by s square plus a square is equal to 1 by a sin 80. So this is the solution for this problem. Hope you have understood. Now let us do second problem. Second problem is find L inverse 4s plus 15 upon 16 s square plus 25. So this is the problem. Now when you solve this problem, as I have told you, first it will be in the form of L inverse f bar s. So I am writing here, given f bar s is nothing but 4s plus 15 upon 16 s square plus 25. So this can be written as, I am writing this separately, 4s upon, now here we have 16 s square plus 25 plus 15 upon, I can write this as 16 s square plus 25. Now I am writing here 4 into s upon, I can take 16 common here so that it becomes s square plus 25 by 16 plus 15 upon, I am taking 16 common again here, this becomes s square plus 25 upon 16, because as you see the formulas, we have to convert in terms of the formulas, so we have to take here common. So here I take 4 by 16 here, and then I write this as s upon s square plus, now I write 25 by 16 as 5 square by 4 square, so I can write this as 5 by 4 whole square, plus in the same way I can write this as 15 by 16 into 1 upon s square plus 5 by 4 whole square. So after taking this, now when you see the formula, now we will write this is equal to 4 by 16. Now you can see the formula here. When you apply Laplace L inverse, so L inverse of s by s square plus a square, so here we have to apply L inverse now. So L inverse of f bar s, that is 4s plus 15 by 16 s square plus 25 is equal to L inverse s upon s square plus 5 by 4 whole square plus 15 by 16 L inverse, again in bracket I can write this as 1 upon s square plus 5 by 4 whole square. Now this is equal to, when you apply the formula, 4 upon 16. Now L inverse of s square, L inverse of s by s square plus a square is nothing but cos 80. So now here this is 4 by 16, so I can write cos cos 5 by 4 t, because as just now I have shown you, L inverse of s by s square plus a square is cos at. So when you see here, this is in the form of L inverse of s by s square plus a square, so I can write cos at. So that is nothing but cos a is nothing but 5 by 4 here into t, then plus 15 by 16, then L inverse of 1 upon s square plus a square. So L inverse of 1 upon s square plus a square is 1 by a sin a t. L inverse of 1 by s square plus a square is equal to 1 by a sin a t. So I can write here as 1 by a. 1 by a in the sense a is nothing but here 5 by 4. So I have to write here 5 by 4, okay, then into sin 80. Sin 80 in the sense sin 5 by 4 into t. Now if you cancel this, this is equal to, now 4 ones and 4 fours, so you get 1 by 4 cos 5 by 4 t, plus now this 4 goes up, so it becomes 4 by 5. 4 by 5, here we have 15 by 16, so when you cancel that, this becomes 3 by 4, okay, because 4 by 5, 5 ones, 5 threes, 4 ones, 4 it comes here, 4 ones are 4 fours, so 3 by 4 sin 5 by 4 t. So this is the solution for this given problem. So in this way we'll do problems based on inverse Laplace by using the formulas. Now let us do the next problem that is somewhat different. These are the basic problems which we have done just now. So we have done 2 problems. Now let us do third problem. Third problem is, here in inverse Laplace transforms we use partial fractions, and this problem will be done by using partial fraction. So third problem is, find L inverse 2s square minus 4 upon s plus 1, s minus 2, s minus 3. So this is the problem. So if this is the problem, you can see in the previous problem there was only one function in denominator, so we'll have, here we have 3 functions. So when you separate this, we will separate by using a partial fraction. Now let us write that so that you can understand. So I can write this as, I can write f bar s, which is given, is equal to 2s square minus 4 upon s plus 1 into s minus 2 into s minus 3. That is equal to, when you write in partial fraction, so this is in the form of capital A upon ax plus b, so I can write this as a upon s plus 1 plus b upon s minus 2 plus c upon s minus 3. Okay, so after writing this, now we find capital A, capital B and capital C. As we all aware of how to find this 2s square minus 4 is equal to, you get a into, and otherwise for your convenience I'll write first this step, s plus 1 into s minus 2 into s minus 3 is equal to a of s minus 2 into s minus 3. We are taking the LCM, and then you will get this one plus b into s plus 1 into s minus 3 plus c into s plus 1 into s minus 2 upon you will have s plus 1 into s minus 2 into s minus 3. Then you can cancel the denominator on both sides, then you get 2s square minus 4 is equal to a into s minus 2 s minus 3 plus b into s plus 1 into s minus 3 plus c into s plus 1 into s minus 2. You get this one. Now we will find capital A, capital B, capital C. How? Let us see. Now here we put s is equal to minus 1 on both sides, so this implies you get 2 minus 4. When you apply minus 1 in s, so you get 2 into minus 1 whole square, that becomes 2 into 1, that is equal to 2, minus 4 is equal to, when you apply in the place of s as minus 1, you will get, I am writing here directly, so that becomes a into minus 3 into minus 4, because minus 1 minus 2 minus 3 minus 1 minus 3 minus 4, then plus b into minus 1 plus 1 0, 0 into something is 0. Again here if you put s is minus 1 plus 1 0, so b and c, these both terms become 0 and this term will remain. So from this implies, now you get 2 minus 4 is minus 2 is equal to 12a, because 3 4 12, minus of minus into minus is plus, so 12a. So this implies a is equal to minus 1 by 6 you get. Now afterwards you have to put s is equal to 2. When you put s is equal to 2, then this becomes 8 minus 4 is equal to, when you put 2 here in this first term, 2 minus 2 is 0, so a becomes 0. Now in b if you put 2 in s, so 2 plus 1 is 3 and 2 minus 3 is 1, so I get b into 3 into minus 1, that's it. Because here c, in c we have s minus 2, so s minus 2 is 2 minus 2 is 0, so a and c will become 0 when you put s is equal to 2. This implies now 4 is equal to minus 3b, this implies b is equal to minus 4 by 3. So we got a value as well as b value. Now we want c value. For getting c value, put s is equal to 3, so that we can get c value here. Now when you substitute s is equal to 3, this becomes 18 minus 4, 18 minus 4, this is equal to, now when you substitute s is equal to 3 here, that becomes 3 minus 3 0, so a becomes 0. Then again in the place of b, here we have s is 3, 3 minus 3 is 0, so b also becomes 0. Now here you get c into 3 plus 1 4 and 3 minus 2 is 1, so this implies you get 18 minus 4 is 14 is equal to 4c. This implies c is equal to, now when you cancel this you get 7 by 2. Now you can see here we got a, b, c values. Now directly we dump here a in the place of a, b, c, so this becomes therefore 2s square minus 4 upon s plus 1 into s minus 2 into s minus 3 is equal to, in the place of a I am writing minus 1 by 6, so minus 1 by 6 into 1 upon s plus 1, because in the place of a we have minus 1 by 6. I am writing here minus 1 by 6 into we have, I write 1 upon s plus 1, then plus b is nothing but minus 4 by 3. So here we have to write minus 4 by 3 into, here we have 1 upon s minus 2, so I write 1 upon s minus 2, plus c is nothing but 7 by 2, so I write 7 by 2 into 1 upon s minus 3. So you got ABC values we have dumped in here in the first step. So after that, after writing that, we have to write this is equal to, once I write this step as minus 1 by 6 into 1 by s plus 1 minus 4 by 3 into 1 upon s minus 2 plus 7 by 2 into 1 upon s minus 3. So after writing this, now we use first shifting theorem of Laplace. Here you can write this as, this is equal to minus 1 by 6 into, I can write e power minus t. When you apply L inverse of 2s square minus 4 upon s plus 1 into s minus 2 into s minus 3. So it's I'll do one thing here, I'll write L inverse of now you can see minus 1 by 6 L inverse 1 upon s plus 1. Now you can see the formula, here we have L inverse 1 upon s plus a is equal to e power minus at. Now here we have L inverse 1 upon s plus 1. So here a is 1, so I can write 1 minus 1 by 6 into e power minus t, because a is 1. Then afterwards minus 4 by 3 into L inverse of 1 upon s minus 2. Again we use the same formula, but here we have s minus 2, here we have s plus 1. So we use here L inverse of 1 by s minus 1 is equal to e power at. So if you use this formula, then we can write this as e power 2t, then plus 7 by 2 into L inverse of 1 by s minus 3. Again it is in the form of L inverse of 1 by s minus a, that is equal to e power at. So I can write e power a is nothing but 3 here, so I write 3t. So this is the solution for the given problem. Hope you have understood. This is the problem and solution of this given problem. Now this is the third problem. Now today we'll stop here, and tomorrow we'll go for first shifting theorem of inverse Laplace transform, and then we'll go for problems based on that, and then we'll go for applications of ordinary differential equation using Laplace transform tomorrow. I think if it is tomorrow, I'll take the class tomorrow, otherwise in next class. Thank you. You can post your attendance now.